now. What are you doing?
You guys ready then?
Kape muna.
Here begins the main tournament to decide the king of Demon World. When the smoke clears, on whom will victory shine? Find out next time as the heads begin to roll.
I came along with Kawaii to this nasty place because I thought it would be fun. Was I ever wrong?
Chorus of technology.
So, how's it going? Suzuka was defeated. He never had a chance in this round. Try and shame it. He's trained pretty hard, he did.
Shishi Wakamura surrenders. That's the Tokushin through to the next round as the winner of Match 8 Group 3.
Yeah, I guess no matter who you are, there's always someone better.
But Toya here's plenty used to this fencing of a superior. Isn't that right, Boya?
Whatever.
Right! Time for the wind to pick up. Listen, Pat, I don't plan to be losing till me and you finish what was begun.
Of course. You'll win this for sure.
Then I'll see you two after I win this.
Same old Jen. No, you focused him and increased his power.
Coming your way right now is the 6th match of Group A. Fighting in this round are Jen and Toketsu, and the Warriors are ready. So let's see how this is going to begin.
A wave he may be, but loads upon loads of power contained inside. I, underestimating this one's the last thing a boy can do.
Wait up, Suzuka! Oh, this kid can be so annoying. Of course, how can he be blamed when he's chasing these kind of looks? Don't run too fast! Oh! Who put that wall there? Hey, Chu.
Rinku, I think it's time you stop chasing skirts and watch. Old Jin needs support from all his best buds.
Yeah? You're just jealous because she's cute.
Not cuter than my own, Sheila. Now let's keep our eyes on the prize for Jin.
Go ahead and change the subject. I can see all the red on your cheeks. Let the match begin!
You use the wind. This should be a challenge.
Well, a challenge you surely got. Now here I go. Oh, great wind. Always supported old Jin, you did, so don't let today be the end. Because if I pull this off, I owe it all to you.
Okay, so it's 7:30, so we'll proceed, no? We are already done with the tension member. So your prelims by next week is a all about tension member. Now, on how we will conduct, actually through online, of course, And ang requirement lang is habang nagsasagot kayo, kasi iyaano ko pa rin kayo sa supervise, naka-open lang yung camera na while you are taking the examinations. So that's the least way I could supervise and check you. Okay? So, syempre pwede naman kayo mag-messenger para magkopyahan. Kaya lang, at least nakikita ko kayo, no? For supervision lang. Okay? So, it will run for 3 hours. 7:30 to 10:30 in the morning. And all about tension member. So, yielding, rupture, black shell. Okay? Then, for now, we will proceed with the compression member, no? So before we move on with the problems, okay, let's have first the concept of on how a compression member is being developed. Okay? So may video ako, I will have to share it. Okay, wait for a while. Okay, so we're done with the tension member, so we'll now proceed with the compression member. Okay, so before anything else, before we proceed with the problem solving, of course, mas madali natin makukuha yung, or mas madali nating may apply yung mga formula kung naintindihan natin kung saan nanggaling yung mga equations from the NSCP. Okay, so let's start to try to derive first. Okay, so for the compression member, it's more on all about buckling. Okay? So, meron tayong dalawang types ng buckling na. So, one is what we call the general buckling. Okay? And the second one is what we call the local buckling. Okay. Pag sinabi kong general buckling, wait, I have a ruler. Nasaan na yung ruler? Ito na lang. Pag sinabi kong general buckling, so, yung buong column mo, okay, magde-deflect siya, okay, magbabuckle siya, no? Okay. Unlike na pag sinabi nating local buckling, hindi pa siya totally nagde-deflect yung buong section, pero it's either minsan doon sa flange, okay? So, yung general buckling, for example, ito yung I section mo, okay? Nagbuckle na siya ng pag-ano, no? Parang nag-buckle na siya ng yan, pag ganyan. Okay. Okay. Buo na siya nag-buckle, no? While the local buckling, sometimes hindi pa siya nagbabuckle, pero yung part ng flange niya, medyo nag-buckle na, no? Or it means some elements already yielded, but not all the cross-sectional elements, no? So, parang part lang. Ang tawag doon local lang. Locality lang, no? So, unlike for the general buckling. Okay? So, those are the two types of the buckling. Okay? Now, it is Euler na who proposed for the critical buckling loads. Okay? So, ihiga ko lang yung column. So, para mas natin. Parang sa beam. Kasi, yung sa beam natin, let's say, ano? Pag tinulak ko yan ng tinulak, okay, tatawagin natin siyang peak critical. Okay, hahanapin kasi natin yung critical load P para mag-buckle siya. Okay? So ngayon, pag nag-buckle siya, so it will be deflected, for example, this way. Okay? And then at any point on the beam or on the column, okay, magkakaroon yan from the original horizontal line hanggang dun sa point na yun, and you will have it for the y. Okay? And then, syempre, kung kukunin ko yung moment at this point, yung moment ko dyan, magiging PCR multiplied it by the y. Okay? Now, from the general equation, yung DE natin, ayan, tinatanong nyo kasi saan ba ginagamit yung mga math natin eh, okay? So, yung DE natin, from the general equation of moment, so we will be having as dx squared is equals to negative m all over ei. Okay? So, sa theory 1 natin, so we have the general moment equation. Okay? Ngayon,
papalitan ko lang si m. Tapos ililipat ko to sa kabila. So this one would become dy squared. D squared, second derivative of y with respect to x. Okay? And then magiging plus na siya. I will have now a PCR multiplied it by y all over the EI. Okay? And then equal to 0. I will let the value of k, okay, to be square root of PCR all over EI. Okay? So ito, para ma-compute ko to, i-square ko yan. So in turned out, it would become equal to d squared y all over dx squared plus ito, from here, magiging k squared. Okay? Pag i-squared ko yun, y equal to 0. Okay? Tapos, ibalik ko sa kabila, no? So, pag binalik ko sa kabila, that would become equal to d squared y all over dx squared equals to negative k squared y. Okay? Next, this one would become m squared from the differential equation we will be having as a squared. Okay? And then, we will now try to solve for the value. Negative to, no? Negative. Negative. We now try to solve for the value of m. So, ang m natin, it's a positive and negative ki. This is now the solution. Okay? Now, we will be having the y equals to, since kapag meron tayong imaginary, so imaginary roots, if we have the imaginary roots, the solution would be in the form of ka cosine, and then the variable k, and then x. And then of course, it is partnered with the sign of k x. You still remember? If one of the if the solution is an imaginary number, we will have this form. Okay? Ngayon, let's have the boundary conditions. Boundary conditions. Okay? So, dito, at your x equal to 0, and here at your x equal to total length of L, of the column. Okay? When x equal to 0, its deflection y is also equal to 0. Remember, you have here the support, so magdi-deflect lang yon. Dun sa start, wala kang deflection, okay? Kaya 0 siya. I-replace ko dito, so I will have it, the y equals to 0, and then a cosine. But k multiplied by x, which is 0, it would become equal to 0. Plus b sine k times 0 is also equal to 0. Okay? So we will have it this one. So yung cosine of 0 is actually equal to 1. So you will be having as a. But the sine of 0 is 0. So this term would be eliminated. It means the value of a shall be 0. Now, ilagay ko dun sa original solution natin. So we will be having as y. Wala na akong a. Okay? 0 na to. Kasi 0 yung a mo. So multiply mo by this term would become 0. So ang matitira is already b sine of kx. So ito na, no? Na-reduce na natin. We'll try to find another value of b. But b, let's have the boundary conditions. When x is equal to L, okay, yung buong length mo, yung ating deflection is also equal to 0. Okay? Lipat ko sa kabila, I will have it as 0 equal to b sine of k L. Yung x mo is also the L. Okay? Now, I cannot say that b is equal to 0. Bakit? Eh de kung nag-0 yung b ko, y equals to 0, it is not anymore, not logical na y is palaging 0. Okay, so in this case, b shall not be equal to 0. Kung hindi mag-equal si b sa 0, paano magiging 0 tong term na to? There's one only possible answer. This one. This sine of KL should become equal to 0. Okay, kasi hinahanap natin value ng b, no? Hindi pwedeng maging 0 yung value ng b. So, para maging 0 to, kailan ba nagiging 0 ang sign? Kapag meron kang 0, kapag ang angle mo is 0, kapag ang angle mo is pi, okay? Kapag ang KL mo, or this one is angle is 0, kapag pi or 180 degrees, kapag 2 pi, kapag 3 pi, kapag 4 pi, ano napansin nyo sa pattern? Okay, multiple of pi lang, okay? Or I could say that KL equals to n pi, okay? Where n is any integer, 1, 2, 3, 4, and so on. Okay? So, ibabalik ko ngayon dun. So, I will now have it as KL. KL. So, we will be having as for this one. Where in the K, papalitan ko na nito. Okay? So, I will have it as KL. So, square root of PCR all over EI. Okay? So, multiply it by L equals to N pi. Okay? So, from here, no? Pinalitan ko lang yung K ng square root of PCI over EI. So, ito yun. Okay. Ilipat ko sa kabila. So, that will become square root of PCR all over EI is equals to N pi or over L. Tanggalin ko yung square root. So, I would have PCR all over EI multiplied it, this one will become n squared, n pi, or over L squared. Okay, ito, ilipat ko na rin yung EI sa kabila. So, I will have it as EI. Okay? But remember the I, that would become equal to, but remember, okay, so yung R natin is square root of I all over 8. Okay, so from the radius of gyration, because we are trying to find for the slenderness ratio, so I could say this one would become R squared is equals to I all over 8. Okay, and then I will try to find for the I, so I equals to R squared multiplied by 8. Substitute this one on this equation, so I will have it PCR is equals to n squared pi squared or over L squared E multiplied it by R squared 8. Okay? Ilipat ko sa kabila to yung A para maging stress na siya, no? Okay, so P over PCR all over 8. Okay? So ano matitira natin dito? N squared pi squared R squared all over L squared multiplied it by E. Okay? Now, what is this N? Okay, so it is a general mode. Okay? So, pag sinabi kong mode, okay, for example, when N equals to 1, when N equals to 1, ang backling lang niya, we have is one backling mode. Okay? That's the mode. When N equals to 2, so we will be having 1 and then 2. When N equals to 3, tatlo naman, ano? 1, 2, and then 3. Okay? And we are trying to find only a fundamental buckling or a general buckling, so we will have it as N equals to 1. When N is equals to 1, this one, PCR, tawagin ko na siya ngayong FCR or critical stress, no? So I will now have FCR or the critical stress, and ang matitira dyan, 1 squared, that would become pi squared, R squared E, or over L squared. Ito, ilipat ko na lang sa baba. So, I will now have FCR equals to pi squared E all over L over R squared. And this L over R is actually called your slenderness. Arian, L over R. That's called slenderness ratio. Okay? So, actually, ito yung ginagamit ni NSCP, yung FCR natin. Kaya lang, there is some modification value of K, which later on, i-discuss natin, okay? So, ito yung dinevelop ni, ang tawag dito? Dinevelop yan ni Euler, okay? Kaya tinatawag yan is Euler critical buckling stress, okay? So, that is actually the stress on the member or on the column para magkaroon siya ng buckling, okay? So, we'll try to further analyze and discuss, okay? For now, we have provided the formulation of the critical buckling stress because everything on the buckling is gamit tong formula na ito. Okay?
Question po so far? May question ba? Okay, so that is the formulation of the critical buckling stress. So kapag tinanong sa problem or sa board exam, what is the critical buckling stress of the column, yan yung formula na gagamitin natin. Ano? Where L is the length of the column and then R is the radius of variation of the column. So later on, we will be having those problems. Okay? However, this FCR is not always true, no? So, sinabi ni, may mga scientists before na sabi niya, hindi naman talaga palaging ganyan, okay? So, doon pumapasok yung ating code, okay? So, nagkaroon tayo ng dalawa. So, kino-consider natin, inaalam natin based sa length ng column, okay? Ano ba yung column natin? Ito ba ay short column? Si Donna ba to? Short? Or is it long column? Si JP ba to? Okay, so pag masyadong matangkad yung column, okay, tandaan nyo, pag masyadong matangkad yung column, bumababa yung kanyang capacity, no? Kasi mas malakas siyang mag-tendency na maputol. Imagine yung ruler na mahaba, okay, nawala yung ruler ko dito. Okay, mas madali siyang, dahil because of its length, teka, kuha ko. Okay. Parang ito, no? Assuming it has the same material, yung isa lang mahaba, yung isa maikli. Okay? Pag in-applyan ko ng same force, for example, ito in-applyan ko ng same force, hindi siya basta-basta magbabakel. Ano? Pero dahil maikli siya, okay, mahirap siyang baliin. Pero yung sa malaki, same force ang i-apply mo, madali siyang magbakel, no? So it means because of the length of the column, bumababa yung capacity. Kasi yung capacity niya, dapat hindi siya bumaba doon sa pagbabakel ng columns mo. No? So, pag nagbakel yung column mo, it means it is now prone to damage and failure. Okay? So, we will proceed with the calculations on how to determine if a certain column is a short column or is it a long column. So, i-continue ko yung video.
Okay, so let's continue with the concept of the compression member now. This time on how they have derived on the equations on the NSCP. Okay, so yung kanina we have the FCR yung from the Euler. Okay, so sa NSCP iba yung gagamitin natin, ano? Let's have it para masanay na kayo. FE ang gagamitin natin. Okay, so for Euler critical buckling stress, we will have it the FE. Okay, so yun yung ginawa niya. Pi squared E all over KL over R squared. Okay? Kaya lang there are detractors from the Euler. Okay, sinasabi nila na, itong formula pala ni Euler na to, hindi yan applicable sa lahat. Okay? So, kasi applicable lang siya for this E. Kaya lang yung E natin, balikan natin yung stress and strain diagram natin. Okay? So, this is, let's say, this strain. And let's say this is the stress. Okay? So, from this one, straight line yan, nandyan yung proportionality natin. So, yun yung ating E, no? Tapos, from here, nagkakaroon na siya ng, sabihin natin, not linear or non-linear, ano? So, sinasabi niya, from here, let's say, ito yung ating proportionality limit. Proportionality limit. Okay? Kapag daw yung stress na nakuha ng column, okay, bago siya mag-bend, is mas mababa sa proportionality limit. In short, nagfo-fall lang siya dito sa region na to. Okay? Mas mababa yung stress niya kumpara, okay, dito sa proportionality limit. And then this one is called on the elastic region. Okay? Kaya ang tawag sa kanya is elastic buckling. Okay? So, other researchers sabi, ito palang formula ni Euler na to, kasi E yung gamit niya, is only applicable kapag nandito sa elastic region, wherein nandoon yung E mo. How about kapag, nangyayari to kailan yan? Let's say masyadong mahaba yung column mo, no? Parang ito kasing equation na yun is para sa mahabang column. Nangyayari lang yan kapag sa mahabang column, let's say yung ruler natin, masyadong mahaba. Wala akong ruler na, nasa na ba? Ito na lang. Okay, let's say sobrang haba niya, parang konting force lang, ano? So, kung konti lang yung force niya, yung F over A mo doon, so, maliit lang yung stress mo, mababa lang yung stress mo, dito ka lang magpo-fall. So, in short, applicable siya sa mga long column. Okay, kaya ito, tinawag siyang para sa long column. Okay? Ngayon, kapag medyo pandak, ayan, parang, sige na nga, parang ako, okay, pandak, bago siya mag-buckle, let's say sobrang liit nung column mo, tapos lalagyan mo ng load, bago siya mag-buckle, kailangan napakalaking stress muna yung kailangan mong dalhin sa kanya or ibigay sa kanya, no? Okay? In short, masyadong mataas yung stress compared dito sa ating proportionality limit, dito na siya nagpo-fall sa inelastic region. Okay? So, on that, ang tinatawag sa kanya is inelastic buckling. Okay? And this inelastic buckling is applicable dahil sobrang lakas para sa tinatawag nating mga short column. Okay? Ngayon, nagkaroon ngayon ng problema. Ito pa lang, formula ni Euler na to is only applicable for the long column. Paano gagawin sa short column? Eh, hindi nga ma-determine yung E kasi non-linear siya, no? So, ngayon, pumasok si Engeser. Si Engeser, siya yung sinabi niya, okay, at this point, let's say, nandito yung stress mo, para makuha mo yung value niya, tinatawag nating tangent modulus, or yung E sa T, no? Yan yung ating tangent modulus. Okay? So, papalitan siya, magiging yung FE natin, magiging pi squared. Lalagyan mo lang naman ng subscript ET all over AL all over R squared. Okay? So, ngayon, sige, tanggapin natin, based on the research, meron lang slight na difference pero quite acceptable. Kaya inadapt ngayon ng AISC. Okay? So, punta ngayon tayo dito sa AISC. Okay? So, now, yung ating formula nakadepende sa ating slenderness ratio. Okay? And then here, yung ating FCR. Okay? Yung FCR natin, ano? Okay, plinat ngayon yan. Okay, plinat. Okay, plinat ngayon si E sub T. Okay, nung plinat si E sub T, okay, dahil ang kailangan niya is masyadong malalakas, okay, parang nandito na siya, no? Mataas yung stress niya, tapos, habang bumababa, okay, habang humahaba yung column mo, bumababa yung value ng FCR. Okay, parang ganyan. Let's say, sample lang, ano, parang ganyan. Okay? So, ganyan ginap. In short, habang humahaba yung column, lumiliit yung stress na kailangan mo. Okay? Now, plinat naman ngayon tong si, ito, plinat naman yung kay Euler. So, kay Euler naman, it's something like this one. Ganyan yung naging graph, no? Okay, so, sige. Ganito gawin natin. Nagtagpo naman silang dalawa at common point, ano? Okay. So, hinanap yung point na yon. Okay, this point. Okay. In 2001, iyon yung ating CC. So, yung square root of 2 pi squared E all over F1. Okay? For 2000, this is 2001. For 2015, so yung CC natin, that is 4.71 square root of E all over Fy. Okay? So in short, kapag daw yung slenderness ratio natin is mas mababa sa CC, tatawagin natin siyang short column. Kapag lumagpas yung slenderness ratio mo in the CC, tatawagin naman natin siyang long column. And then this time, for the short column, ang gagamitin nating formula is formula ni Engeser. So you will have it as pi squared E T all over KL all over R squared. Kapag long column, gagamitin natin yung kay Euler na pi squared E all over KL all over R squared. Okay? Ngayon, on the AASC, binigay yan. So you can have it as FCR. Okay? Parang inano na natin, ano? So we can have it as 0.658. We will have it as Fy all over Fe multiplied it by Fy. Okay? So this is for the short column. Okay. I-post ko nandyan siya. So you will be having as 4.71. Kapag mahaba, 0.877 of Fe para sa ating long column. Okay? Wherein the Fe is this value. Okay? Wherein the Fe is already pi squared E all over KL all over R squared. Okay, take note kahit short column siya, minodified na yan ng AASE. Kaya in terms of Fe na, kasi mahirap hanapin yung ET. Okay, so they have derived an equation for this one. So for the short column, 0.658 Fy all over Fe multiplied by Fy. And then for the FCR, you have it 0.877 of F sub T. Okay, yung between niya, again, the CC. Okay, so again, the general rule, you have to check first if based on the slenderness ratio, your column would be a short column or is it a long column. Okay? So, ano yun? Sa boundary ng CC. So, that is the difference between 2001 and 2015 NSCP. Okay, so
Okay. Balik ko ng kaunti. Ayan, okay. So that is for the compression members, So just to give you an idea, so nagbigay ako sa inyo ng handout, okay, nag-send ako. So ito siya. So design for compression. Ito ay galing kay AASC mismo. Although ito rin yung kay NSCP, kaya lang malabo kasi yung kopya ko ng NSCP, so mas malinaw to. Anyway, kinopya lang naman ng NSCP, no? So ibig sabihin, mas tama ito. So, minsan may mali pang kopya, papakopyahin na lang ng Pilipinas na mali pa eh. Okay, so ito ginagamit ko for the design of the compression members. Okay? So, meron tayong 7 pag-aaralan. Okay? E1 to E7 for this one. Okay. So, unahin muna natin yung general provisions. So, we will be having here, as sinasabi lang dito, so the general or allowable and then the design strength. Okay? So, meron tayong parang dalawang klase. Isang symmetric at saka isang non-symmetric. Okay? When I say symmetric, okay, or doubly symmetric, parang ganito yung magiging itsura niya, no? For example, yung I section ko. So, I will be having here the I section. Okay. Para siyang naka-mirror. Kapag kinat mo sa vertical, symmetrical sila. Kapag kinat mo horizontally, symmetrical pa rin sila. So, this is called a doubly symmetric. Okay? This is a doubly symmetric section. Okay? Kapag naman, for example, I have here the cross-sectional T. Okay? Sa vertical, it is symmetric. But the horizontal, it's not symmetric. And then this is called a unisymmetrical. Symmetrical. Okay. So, isa lang, no? Kapag naman ginawa natin unsymmetrical, for example, we will be having here the angle section. So, this is not symmetrical vertically and then not symmetrical horizontally. So, this is unsymmetrical section. Okay, so meron kang tatlo. Now, ano yung cruciform? Yung cruciform para siyang cruise na pinagsama-samang mga angle bars. Okay, so this is called the cruciform. Okay? So yun yung sinasabi ng AISC. Sinasabi niya, okay, yung atin daw flexural buckling, by the way, yung tinuro ni Euler, okay, yung pagbabuckle nito, nasa ng aking ruler, okay. Yung pagbabuckle niya ng buo, okay, ang tawag natin dyan is flexural buckling. So, sabi ni NSCP or sabi ni AISC, kahit daw doubly symmetrical ka pa or singly symmetrical ka, dapat daw yung flexural buckling is chine-check natin. Okay? So, it means the flexural buckling is always applicable to any compression members. Okay? So, yun yung number 1. Ngayon daw, sabi niya, pag meron kang symmetrical and unsymmetric members at yung ibang doubly symmetric members such as cruciform or built-up section. Okay. So sabi niya kapag daw ganito yung itsura, okay, for singly symmetric o kaya unsymmetrical and some, kasi itong part na to, kung titingnan nyo, doubly symmetrical naman siya, di ba? Okay, kaya lang, these cases, okay, built-up section siya. Kapag sinabi kasi nating built-up section is kahit isang member ka, let's say isang angle bar ka lang, pinagsama-sama mo siya para maging ganito, ang tawag natin doon is built-up section. Ibig sabihin, isang section lang siya pero pinagsama-samang maraming sections. So, sabing AISC, if you have the built-up section, and then dapat i-check natin yung limit ng torsional or flexural torsional buckling. Ano naman yon? Torsional kasi minsan pag nagko-compress siya, umiikot ng ganun yung column mo, tsaka siya mababaling ganun. Okay? So that is the torsional. As well as the, what you call this one? The flexural torsional. Kasi minsan, halimbawa, gusto niyang mag-buckle on this direction, gusto niyang mag-buckle on this direction, pero pipiliin ko siyang baliin, ano? Kaya lang kaya niya mabali, pero tingnan niyo yung nangyayari dun sa pinaka-ruler mo. Okay, para siyang, ayun, nakukupi yung pinaka-web, di ba? Okay, ang tawag natin doon is actually flexural torsional. Ayan, parang gumagano, no? Pag binali kong ganun, ayan, nakita niyo yung ruler. Ang tawag natin doon is the flexural torsional buckling. Okay, kapag daw, again, unsymmetric or unisymmetric yung isang member, at saka built-up section, we need to check for the torsional and flexural torsional. So, meron na akong tatlo, no? So, una, flexural buckling, flexural torsional, and then the torsional buckling. Okay? So, meron kang tatlo. Next. Okay. Slender limitations, ito yung may value of K. Okay? So, before we proceed, okay, let's watch first the tutorial on the K value. So, ito na yun.
Column 0.65 FCR will be a short column 2015 NSCP. Again, we just need to determine if the column is short or long, nakadepende sa kanilang slenderness ratio. Okay, yung slenderness ratio niya, yung KL all over R. Okay, so later on we have...
Okay, so ito po, yung nasa left side, yung allowable stress na nakalagay. This is for the NSCP 2001, okay? So, by the way, pagdating natin sa compression member, dalawang code yung ituturo ko, no? Kasi pagdating sa board exam, minsan hindi natin alam kung ano yung ginagamit ng examiner. Although, sinabi ng examiner last time na 2015 yung gagamitin, kaya lang, wala pa yung board exam na yon. Baka mamaya, pagdating sa inyo, biglang magbigay ng 2001 NSCP. So, kailangan matutunan nyo both the 2001 and then the 2015 NSCP. Again, this one is for 2001 NSCP and then the right side is the 2015 NSCP.
Two axis yan, no? Pagdadaanan natin lahat yan. Okay? Ngayon, on 2001 NSCP, ito yung value ng CC natin, 2 pi squared E all over the Fy. Okay? While on the 2015 NSCP, we have already 4.71 square root of E all over Fy. Ngayon, you try to solve for this one and it is approximately 4.44. Okay? So, medyo mas mababa ng konti kumpara kay 2015 NSCP. But, medyo hindi naman nagkakalayo. Okay? Ngayon, for short column, okay, ito yung modified na Engelsor equation or tangent modulus, no? Para kay 2001 NSCP, you have the factor of safety na mahaba. Ang haba. And then for long column, Euler lang yan, tapos meron ka lang factor of safety. Okay, we are in 23 all over 12. Okay? Kapag kay 2050 naman at short column ka, ito lang yung gagamitin mo. 0.658 FCR ang nakukuha natin. And when KL over R is greater than CC, you have here the FCR. Okay? Wherein, ito yung Euler critical buckling stress natin, pi squared E all over KL over R squared. And then, para makuha natin yung nominal axial, yung FCR na makukuha natin, imumultiply natin by the area. Okay? And then, we will be having already the PU for the LRFD, PPN, para lang yielding. And then for the allowable, you have divided by omega or the factor of safety 1.67. Okay? Now, kanina pa natin binabanggit yung K. Okay? Pero hindi natin alam kung anong values niya. Okay? There's a table. Unfortunately, on the table, I guess in the board exam is hindi naman siya given. Okay? So, in other references, may makikita kayo doon, no? Isang theoretical at saka isang recommended. Okay? So, theoretical, normally, if you are going to analyze a certain structure, you may use the theoretical. And for the recommended, kapag naman magde-design ka, you try to use for the recommended values. Okay? So tayo, we will try to have only the theoretical. In the board exam, theoretical naman yung ginagamit. Okay? So actually, the effective length factor is may kinalaman dun sa distance ng point of inflections, no? So, pwedeng i-derive naman, okay? Pero mas padaliin natin ng konti, no? Kasi minsan nakakalito, alin dyan yung 1, alin yung 0.5, alin yung 0.7. Parang tatlong values lang naman, ano? 0.5, 0.7, 1, and then 2. Okay. So, since it is a point of inflection, ilan na rin natin na parang sa deflection lang. Example, ito yung column ko, no? Ito yung column ko. Okay? Unahin muna natin tong fixed to fixed, okay? If I say the fixed, okay, hawakan ko siya ng ganyan, okay? And then pag hinawakan ko siya, lalagyan ko siya ng load, and you will try to see kung paano siya magde-deflect, okay? I'll try to have it this way. Okay? If you see the deflection, okay, i-drawing ko yung deflection niya, parang ganito yung naging deflection. Dito banda, straight pa siya, tsaka dito. Pero from there, nag-start na siyang mag-buckle. Okay? And that buckling, okay, mula dito hanggang doon is around 50% of the length. Okay, so ito around 25%, kaya 0.25 eh. Ito another 0.25. So yung talagang nag-buckle lang, yung parang point of inflection natin doon, okay, it's around 0.5 of L. Kaya ang key value natin is 0.5. Okay? So let's try to find first the fix and then the pin. Okay? Kapag fix sa hawakan ko, kapag pin, ganito lang ano. Okay, so I'll try to have it deflection and it will behave like this one. Okay, if you still notice, okay, I will draw the deflection. Okay, from here, para siyang straight pa siya dito. Pero from there, ganun na yung buckling niya. Mas mataas ng konti dito and that is around 70% of the length. Kaya nagkaroon ka ng 0.7 of L. Kaya ang K value mo, or effective length na magdi-deflect is only, or magbabakel is around 70% of the length. Okay? For the fixed to fixed, so para ay pin to pin ganyan, pag tinulak ko ganyan, ayan, nakita nyo buong length yung nag-deflect. Okay? So kung buong length yung nag-deflect, okay? So automatic na 1.0 of L. Kaya ang value mo is 1.0. Okay? Pag medyo nakakalimutan mo yung values, imaginein mo lang, okay, magdala ka ng ruler, okay, ganunin mo. So, medyo mas maano mo siya. Basta tatlo lang yung values na 0.5, 0.7, and then 1.0. Again, this is without translation. If I say without translation, yung taas at baba, hindi gumagalaw, okay? Parang ganyan. Pero in most of type of structures kasi, kung meron kang lateral load like earthquake, nagmo-move siya, no? So, nagsisway siya ng ganun, okay? Sa top. Okay, so if without translation, normally ito naman yung given sa board exam, without translation, no? Kung meron kang nagta-translate sa taas or part of what we call the sway frame, okay, so ito pwede to sa non-sway frame, no? Non-sway. Ito, pwede to sa sway frame, okay? So paano siya? Fix and then fix ulit. Kaya lang this time magta-translate ako, no? So pupunta, nakita niyo yung deflection. It will behave this one for fixed and then fixed. Okay? Parang ganito, ayan. Parang ganyan. Ayan. Sir, nasan yung 1.0 dyan? Okay? So, sabi natin kanina, kailangan kasi yung buckling length natin parang point to point, no? So, let's say dito nag-start. Okay? Gitnang-gitna, ano? So, that's around 0.5 of L. 0.5 of L. Kaya lang, kailangan may katapat siya. Okay? So ngayon, wala siyang katapat, maglalagay tayo ng imaginary length. Ano? So, same lang ng length na yon, para lang mabuo natin yung buckling length na to. Okay, imaginary buckling length So that is 0.5 of L and 0.5 of L. So this is around 1.0 of L. Kaya ang K mo is 1.0. Okay? So, how about the cantilever? Okay. So, tingnan natin cantilever. Fix dito. Pero ito mag-move ng pagganyan. Kung makikita nyo, ito yung backing niya, no? So, ito yung deflection niya. So, this one is your deflection. Dito na lang. Pag hindi deflection mo. Pero kailangan nito may katapat. Walang katapat. So, gagawa ko ng imaginary. So, L and then L plus L. So, you have K equals to 2.0 of L. Okay? Same thing dito, ganun din. So, you have here the pin and then fixed. So, magmumove na ganun. So, parang cantilever lang din siya, no? Yung nangyari sa kanya. So, same thing. So, ito, para magkaroon, another L. So, L plus L. So, you have here the 2L. Okay? So, I guess that's for now. For now, no? So, those are the concepts na kailangan natin matutunan.
Okay po. So, sige, I will give you time to copy and then have the lectures on the compression members. Okay. So, bigyan ko kayo ng 5 minutes break and then we'll proceed with the calculations afterwards. Okay. Good morning, JP. Kakapasok mo lang. Late ka na naman. Pati dito late ka.
Sorry, sir.
Sige na. Ano muna kayo? Break muna and then we will proceed with the calculation afterwards. Okay, so welcome back to our channel. Ay, to our class. Okay. So, here is the problem. Nandiyan na ba lahat? Okay. A W12 by 50 is used as a call. Pwedeng i-open yung mga ano nyo, camera nyo para may parang feeling ko may kausap ako. Ang hirap nang walang kausap.
Morning, sir.
Good morning. Ayan. Parang meron naman akong kausap. Ang hirap pag walang kausap eh. Si Don nangingiting-ngiti lang. Oh. Ay, picture pa lang pala yun. Wala si Donna. Tsaka si JP, tsaka si Mitzi. Wala yan dyan. Tingnan mo. Naka-open lang yung Zoom pero wala. Alam mo, hindi rin mga nag-response. So, wait lang po, eh. Ayan si Mitzi, oh. Pero si Donna tsaka si JP, wala yan dyan. Natutulog yan, in-open lang yung Zoom. Donna.
Sir, wait lang, sineset up pa.
Sineset up pa. Si Donna, wala. Tulog si Donna. Wala talaga si Donna, no? Absent si Donna ngayon, ha? Okay. However, let's proceed, no? So, a W12 by 50 is used as a column to support an axial load of 645 kilonewton in compression. So, the length is 6 meters and the ends are pinned. Determine the overall factor of safety against the buckling. Okay. So, yung W, that is a wide flange section. So, for example, ito yung wide flange natin. Okay. Yan. So, let's try to draw it. Ayan. So, ayan yung ating wide flange section. Ano? Then, yung cross section kasi natin, parang ganito yung cross section natin eh. Okay? Tapos, dalawa yung axis niyan, di ba? So, the horizontal axis is the x-axis and then you have here the y-axis. Okay? So, bawat axis, meron kang R. Okay? So, ayun, given yung isa, yung Rx, and then dito, may given kang Ry. Para saan yon? Okay? So, para dito yon, so, in ano ko, this is the x and then this is your y-axis. No? So, depende kung paano siya mababali. Okay? So, parang right thumb rule. For example, ito yung y mo, ito yung y mo. So, yung right thumb mo, ituturo mo dun sa y. Okay? Let's say, yan yung y mo. Ituturo mo yung thumb mo dito sa y. Okay? Thumb yan. Okay? Tapos, papaikutin mo ng ganun yung inyong daliri. Yan. Okay? So, parang ganun. So, kung paano siya mag-buckle against y, so, it means kung magbabuckle yung y ko, okay? Pag ganun yung buckling niya. Okay? Pag ganun. Okay? Kung na-imagine nyo, parang kung ito yung y-axis natin, yung local y natin, ito yung y mo, so magbabakal siya ng paganto. Okay? Kapag x naman, so dun mo naman ituturo yung right thumb mo. Okay? So you need to point the right thumb here. Tapos papaikutin mo ng paganon yung inyong ano. Okay? So let's say ito naman yung x ko, this is the x-axis, papaikutin ko naman ng paganto. Okay? So, ganun yung buckling niya. So, it means we need to check both on the axis, both on the x-axis. Paano yung buckling nito? Kumbaga, yung buckling ng y, okay, parang ganito yung naging buckling ng y. Okay, parang naging ganyan. Hirap kasing i-drawing eh. Ayan, parang naging ganyan yung buckling ng y, ano? Ayan, parang, ayan, that is... si JP nasa ano ah. Okay, so this is buckling about the y-axis. Okay. Now, yung buckling about the x, parang ganito naman yung buckling about the x. Ang hirap i-drawing. Imagine natin na ano no, i-top view ko na lang. Ang hirap i-drawing eh. So, for example, ito yung top view mo. Okay. Top. Ito yung front view, no? Ito yung front view. So, sana na-imagine nyo. Ito yung column. Ayan yung front view. Again, this is the x eh. This is the x-axis. And then this is the y-axis. So, yung pagbabuckling niya, pag ano naman. No? Pag ganito yung buckling niya. Okay? So, about the x. Okay? So, we need to check both the axis, ano? Both the axis, x, and then the y-axis. So, ngayon, ang i-check natin doon is actually the slenderness ratio itself. Okay? So, una, kukunin muna natin yung kanyang KL all over R. Okay? So, solve for slenderness. Slenderness ratio. Okay? So, about x, okay? So, this is tawagin natin KL all over R on the x direction. Okay? Since ang sinabi sa problem is pinned, okay? So, ang value ng k natin is equals to 1.0. So, you will be having here 1.0. And then yung L, it is the length of the column na nagbuckle, okay? So, there are cases, no? For example, good morning, Donna. Ayan na si Donna. Okay. For example, meron tayong column, okay? Tapos may support siya dyan. And let's say ito yung column natin. Support, okay? Pero pagdating dito sa gitna, meron na akong beam. Say meron na akong beam dyan. Somewhere at the middle, meron na akong beam. Okay? Uulitin ko, this is the x-axis and then this is the y-axis. Okay? Now, yung pagbabakel sa x-axis, okay? Kasi ang buckling niya pag ganito, no? Ayun, pag ganon. So, ibig sabihin buong length, kung nai-imagine nyo, okay? Kumbaga, if this is the x-axis, okay? Magbabali siya ng pag ganon, okay? Buong length niya yung mababali, ano? Okay? So, ibig sabihin, buckling about the x, yung Lx ko is equals to buong length. Okay? Now, when I say buckling about y, so ito yung papaikutin natin, ano? So, supposedly pag ganyan siya, kaya lang meron siyang beam dito sa gitna. Excuse me lang, may tumatawag. Okay. Interruption. Ayun. So, meron akong backlink kung y naman siya. Again, this is the y. Kaya lang meron akong beam sa gitna, ano? So yung beam ko sa gitna, puputulin niya yung aking backlink. So para magiging dalawa yung backlink niya, no? So dahil meron ako ditong magbabakel dito at saka magbabakel doon. It means yung nagbakel lang na length sa kanya is only L all over 2. For example, ganyan ano. So, yun yung kaibahan ng dalawa. So, you need to check the column. Sometimes, ito sinasabi niya, later on, okay, the buckling about the weaker axis is L all over 2. Okay? Or meron daw support. Basta meron kang support sa gitna, okay, nahahati yung buckling natin. Okay? Kaya nga kapag bumababa yung capacity dahil masyadong mahaba yung column, ang ginagawang solution, okay, lagyan natin ng support sa gitna. Nilalagyan nyo ng beam sa gitna, okay, para maputol yung buckling length natin. Okay? Dito sa problem natin, wala namang support sa gitna sa kahit ano. So, kapag ano nang binigay, both the LX and LY, buong length ng column yung magbabakel natin. Okay? So, let's have it 1.0. 6,000 ang gagawin nating L. And then, yung RX natin na gagamitin is 131.5. Okay? So, ano natin? 6,000 all over 131.5. So, you will be having here as 45.63. Okay? So, dapat daw yung slenderness ratio ng kahit ano, it should be less than or equal to 200 para maging code compliant. Kapag sumobra ka sa 200, ibig sabihin bagsak na yung column mo. Hindi siya pwedeng gamitin. Okay? So, now check natin sa y-axis, KL all over R, Y. Okay? So, 1.0 multiplied by 6,000. Okay? Divide natin by the RY of 49.71. So, we will have it as 49.71. So, that's around 120.70. Okay, so again, less than 200 and then this is a compliant. Okay. Now, kung sino yung mas mataas, bigger, okay, so that is the governing axis. Ano yung ibig sabihin ng governing axis? It means dun siya prone na magbakel. Okay, kung sino yung mas mataas na slenderness ratio, ibig sabihin that axis yung mas prone sa buckling. Okay, so for example, this is the x-axis, and then this is the y-axis. Okay, yung KL over R sa y-axis is mas mataas. Ibig sabihin, mas maano siyang mag-buckle on this direction kesa dun sa kabilang direction. Okay? So, it means, ang gagamitin natin, this one is the 120.70. So, that is the governing axis. Now, ang tinatanong natin dito is the overall factor of safety. So, ibig sabihin, for overall factor of safety, okay, ito yung ano natin is capacity all over the load. Okay? So, meron tayong load. Yung load natin, actually, yun na yung ating 645 kilonewton. So, 645 kilonewton. Ang kailangan na lang natin kunin is this capacity. Okay? So, for this capacity as against the buckling, so we will have it the critical. So, we will be having the Euler critical buckling load. Okay? So, ano yung formula ng PCR natin? So, PCR, again, that is the pi squared E. Di ba? Meron tayo kaninang KL all over R. Okay? And then this one is Y. Kaya lang over A. So, ilipat ko na dun yung A. Kasi P over A yun, critical buckling stress, no? So, ito na yung magiging formula natin. So, we will be having pi squared. Ang E ng steel, okay, hindi ko na ulit uulitin. So, that's around 200,000. Okay? So, ang A natin is 9484. Okay? All over. KL over R natin is 120.70. Okay? So, ang ating PCR is equal to okay. And then you divide it by 1,000 para pi squared E all over KL all over R. Sorry. This is squared, no? KL over R squared. So, i-divide natin by squared. Okay? And then you divide it by 1,000. Okay? You divide it by, that's 128,000, 128,5010.707. Again, naka-Newton yan. So, ang R natin is around 1,285.01 kilonewton. So, ito na yung ating capacity. Okay, that is your capacity. Okay? So, to get for the factor of safety, so that would be the capacity 1,285.01, and then we divide it by the load of 645. So divided by 645, so that's around 1.99. So this is now the factor of safety. Kapag yung factor of safety mo is nag-less than 1, it means bagsak yun, ano? So dapat palaging greater than or equal to 1. Okay? Para maging acceptable yung member mo. Okay? So minsan sa site, kuwari tinanong, engineer, pwede ba natin gamitin tong ano na to, size na to? Okay. Hindi minamata-mata, no? So, maraming ganun na, pwede na yan. Walang ganun. So, kakomputin nyo. So, against the load and then yung capacity, so dapat mag-greater than 1. Kapag nag-less than 1 ka, ibig sabihin, bagsak yung member mo. Hindi mo dapat ipagamit yun, ano? Okay. Sige, kopya. Okay, save ko rin to. Okay na? Okay. So let's have a second problem. So may pansulat ko ayun. Okay, so let's have the problem number 2. A W14 by 74 of A36 steel has a length of 6 meters and beam ends. Compute the design compressive strength and allowable compressive strength. Okay? So again, dalawa pa rin yung methods natin sa 2015. We have the LRFD and then we have the ASD. Okay? By the way, given na pala yung properties, no? So yung area, pakidagdag 14,046. I see, 64. Okay. Again, lahat to no nandun sa table natin na binigay. All right. Okay? So since yung length natin, both the LX, okay, LX is also equal to LY kasi wala naman tayong support at sa kahit anong axis. So equal yan sa L natin and that's around 6,000 mm. Okay? Kapag parehas si LX at saka si LY, okay, ang kukunin na lang natin na R, okay, ito na lang ang kailangan natin. Find, okay, if LX is equals to LY, use smaller R, okay, or smallest radius of gyration. So in short, i-check na lang natin siya sa y-axis. So for this case, check
for y axis. So, ibig sabihin yung x-axis, automatic na yan, hindi yun mag-govern. Ano? So, ang governing palagi is yung mas mababang r. Okay, kapag, uulitin ko ha, kapag magkamukha lang si LX at si LY. Pero kapag magkaiba si buckling length ng X at saka ng Y, you need to check both kung sino yung mag-govern. Okay, so slenderness, ratio. Okay, so we will be having as KL all over R. So ang governing natin, again, this is pin. Okay, so sinabi doon, pinned ends. So ibig sabihin, ang K ko 1.0. Okay, ang L ko is 6,000. Okay, and then ang Y ko, ang RY ko is 62.97. So let us check. Oops, nasa na ang aking calculator. Diba? Mag-isa ako dito, nawawala yung mga gamit. 6,000 over 62.97. So you will be having here 95.28. Okay? So again, this is less than 200. So acceptable yan, ano? Okay, kapag nag-greater than dyan, so that is not acceptable. Okay? So okay tayo. Then you need to check. So sabi nga natin, okay, parang dun sa graph natin, ano? Okay, ibalikan ko lang yung graph. Okay, so this is the KL all over R. Okay, tapos i-check natin siya dito sa gitna. So ito yung ating CC, ano? Okay, so yung for CC natin, okay, for NSCP 2015, that's 4.71 square root of E all over FY. Okay, so check natin yung CC natin for this one. So 4.71 square root of E all over the FY. Okay, so ang FY na gagamitin natin, walang binigay, 248. Okay, so let's check this 4.71 square root of 200,000 all over 248. So that's around 133.76. Okay, so dapat yung slenderness mo dyan, hindi lumagpas dyan para maging short column. Okay, so since KL over R, okay, KL all over R natin is less than CC. Okay, so this is a dona. Ay, short column pala, short column. So this is a short column. Okay? Kapag lumagpas ka dyan, sa CC, JP naman. So it's a long column, ano? Okay. O, manilin na lang. Pwede rin manilin kung short column. Okay? So, based on the NSCP, if this is a short column, ang gagamitin nating FCR. Okay? So again, this is called the critical, okay, buckling stress. Okay, anong gagamitin natin? So that's around 0.658 multiplied by Fy raised to Fy all over Fe. Okay, multiplied it by the Fy. Okay, so first, what is now the Fe? Okay, so kunin natin yung sub Fe. That is pi squared E all over KL all over R I squared. Okay. So we have here pi squared. E natin is 200,000 all over. KL over R natin, that's 95.28 squared. Okay. So you will be having here the Fe. So that's pi squared E all over KL over R 95.28 squared. Okay, so that's around 217.43. Again, ang unit niyan is megapascal. Okay, so we need now to compute for the value of FCR. So that's around 0.658. Ang Fy natin is 248 all over 217.43
multiply natin by Fy of 248. So this is now our 0.658, 248 all over 217.43 multiplied by 248. Okay, so that's around 153. Okay? 0.86 megapascal. Okay? So this is now your FCR. Okay? Para makuha natin yung PN or nominal. Okay, nominal. So that is equals to FCR. Multiply lang natin yan by the area gross. Okay? So we will be having here FCR 153.86 multiplied by 14,064. Okay, mm squared. Okay, para maging kilonewton, i-divide na natin by 1,000. Ano? So we will be having here this PN. So ang PN natin, 153.86 times 4,064 all over 1,000. So that's around 2,163.89. Again, this is in kilonewton. Okay? So, gagamitin natin dito is, yung factor is parang sa yielding. Ano? So, we will use for the yielding, so we will be having as PU 0.9 of P sub N and PA equals to PN all over 1.67. So, ito yung ating VPN. Ano? 1 point. Ito yung ating VPN. Ito yung ating PN all over omega. Okay? So, for the LRFD method, okay, so this is the design strength. Okay? So, we will be having here PU, so 0.9 of PN. So, we will be having PU 0.9. Ang PN natin is 2,163.89. So, solving for PU, 2,160.89. So, that's around 1,947.50. Okay? And this is now in kilonewton. Okay, so here is the answer for the design strength. Okay, so punta naman tayo for the ASD. So this is now the allowable naman, ano? Allowable strength. Okay, so we will now have PA, so that's PN all over 1.67. So that is equal to, ang PN natin, 2,163.89 all over 1.67. So you will be having here the PA. So that's around 1,295.74 kilonewton. Okay, so this is now the answer. Okay, so we have the allowable and then we have the ultimate. Okay, so ito yung capacity, no? So kung matatandaan nyo before, okay, nung kayo ay grade 6, okay, nagme-method of section kayo, di ba? Nagme-method of joints kayo dati. Okay. Tapos, di ba may mga loads yan? Yan. Tapos, pinapakompute sa inyo yung mga bar forces. Tama ba ako? Okay. So, let's say itong bar forces nyo to. Let's say AB. Okay. Compute sa inyo, di ba? Bar force AB. Let's say, nakuha mong bar force AB. 1,000 kilonewton. Ayan. Nilalagay nyo pa nga ganyan eh. Compression, di ba? So, ito yung galing sa loads. Okay. You need to compare this one dun sa atin. It's either allowable or ultimate. Okay? So, dapat laging mas malaki yung capacity mo kumpara dun sa mga loadings mo, no? Para maging safe siya. Okay? So again, yung kino-compute nyo dati sa theory of structures, lahat yon is the load based on the loads. So ngayon, ang kino-compute naman natin is capacity naman ng members. So dapat yung mako-compute natin palagi, mas mataas yung capacity over the load. So pwedeng sa exam, okay, for example sa exam, nagbigay ako ng truss, ng loadings. Tapos pinapa-design ko to. Kaya lang ang lumabas dito, 1,000 kilonewton intention. Let's say intention. So, ang gagamitin mong pagkuha ng capacity, yung topic natin noong nakaraan. So, how to compute for the tensile capacity. So, dapat mas malaki yon kumpara dito. Okay? Or ipapadesign ko sa inyo, di ba? Meron tayong design. Given the loadings, ito yung loadings, hahanap ka ng section na mag-save doon sa loadings. Okay? So, ito yung kinocompute natin. Kung bakit natin siya kinocompute is to compare the capacity to the loadings. Okay? So, sige po, kopya muna and then we'll proceed with the next example. Si JP natutulog pa yan eh. Naman hindi nagsasalita. Oh, ha?
Dito ako, sir.
Narinig na ko, napapunta na, pabalik na. Ah. Sige nga, JP, para sa ng slenderness ratio.
Ano, sir? Acceptable na pag-bend nung column?
Okay, sige. Pwede na sa backlink.
Yun, sir, sa backlink.
Ba't wala kang camera? Sayang GoPro mo. Ganda-ganda eh. Tingnan mo si Dan. Ganda ng background do Dan. Ikaw ba nagpintura niyan?
Wallpaper lang, sir.
Wallpaper. Maganda parang kay Mimi Yu. Kay M.
Sir, nasa kapitbahay ako.
Sa kapitbahay ka. Wala kang internet.
Wala po, sir.
Hirap talaga ng online eh.
Tamang connect lang po sa piso wifi.
Ay, naka-piso wifi ka?
Opo.
Hindi ang gastos. Piso per ano yan?
Sobra po. Bali, ang 5 pesos, ang piso po ay 5 minutes.
Ay, ganoon.
Tapos, ang 10 po ay 1.5 hour.
Ang 10 pesos.
10 pesos po, 1.5 hour.
Okay. So, ibig sabihin kung ang klase mo pala, ay grabe.
Opo, sir. Sakit po sa bulsa.
Kaya nga eh. Pero kung ano ha, pwede kang hindi alive kung sakasakali iyan mo na lang kung mapapamahal ka, ina-upload ko naman para lang kasi baka sakit sa bulsa eh.
Opo, sir. Thank you po.
Okay? So, next is same example, kaya lang gagamitan naman natin ng 2001 NSCP. Ano? Okay, ano ko na yung iba muna. Okay, same hanggang dito. Okay. So, baguhin ko lang to on this part. Okay. So, for the CC, okay, 2001. So, 2001 tayo. Kaya bago naman kay 2001 is our CC, no? So, yung CC niya, so that's around 4.44 or that's square root of, okay, 2 pi squared E all over Fy. Okay? So, check natin. So, that's equal to 2 pi squared E. 200,000 all over the Fy of 248. Okay? For a certain still like A36, constant na yan, ano? So, okay lang sa exam, hindi nyo na ipakita yung ganyan. So, ngayon lang natin kakomputin kasi first time natin computin. All over. So, that's around 126.17. Okay? So, this is constant for A36. Okay? So, pwede nyo nang tandaan yan, 126.17 kapag mas mababa yung slenderness ratio mo sa 2001, ha? Okay. So, short column ka. So, again, since KL all over R is less than CC, so therefore, again, this is DONA. Okay. So, short column. Okay. Kaya lang ito, i-require ko kayong kabisaduhin na. So, kapag nag-board work tayo, ang isa sa board work is i-recite nyo. Kailangan sa camera nakatingin na kasi baka mamaya meron ka sa likod na kodigo. So, i-recite mo sa akin yung formula, ha? Tapos dapat sa camera nakatingin. Hindi pwedeng bibingalinga. Ibig sabihin, meron sa likod ng camera ang formula. Okay? So, kailangan kabisado, ha? So, again, yung FA natin, yung pre-project ko kanina, so that is equals to, mahaba kasi to, 1 minus 1 half KL all over R over CC squared multiplied it by Fy and then you divide it by the factor of safety. Okay? Ngayon yung factor of safety natin, yun yung 5 all over 3 plus 3 all over 8 KL all over R over CC cube KL over R over CC plus 1 all over 8 KL all over R over CC and then this is cube. Okay? Kailangan kabisado yan. Okay? So 1 minus 1 half KL over R over CC squared times the Fy all over 5 over 3 plus 3 all over 8 KL over R over CC plus 1 all over 8 K all over R over CC cube. Okay? So college ko pa natutunan yan. Hanggang ngayon kabisado ko. Dapat kayo kabisado nyo rin, ha? Okay. So, itong term na to, para hindi kayo mahirapan, computein muna natin. Ano? So, we will be having here KL all over R all over CC. So, again, that's 95.28. Okay? And then, we divide it by around 126.17. Tapos, i-store nyo na lang sa calculus nyo para saktong-sakto tayo. So, 95.28 divided by 126.17. Okay. Sanay naman kayo mag-store, di ba? Okay, store. Okay. So, store. Okay. Tapos, i-compute natin si FA. So, we will be having here as 1 minus 0.5 ko na lang, no? Okay. And then, we will be having here 0.755 kasi. Okay. 0.755. And then, squared. Multiplied it by 248. Okay. Over 5 all over 3 plus 3 over 8. Okay.
and then 0.755 plus 1 over 8, 0.755, and then cube. Okay. So we will be having here our FA. So 1 minus 0.5 of A squared. 248 all over 5 over 3 plus 3 all over 8 KL over R plus 1 all over 8 cube. Okay, so we will be having here as our FA equals to 88.48. Again, the unit is in megapascal. So to solve for the allowable, so that is equal to 88.48. Okay, mumultiply natin by the area, no? So yung area is 14,064. And then you divide it by 1,000 para maging kilonewton. So you will be having here the allowable. Times 14,064 divided by 1,000. So that's around 1,244.37 kilonewton. Okay? So this is now the answer for the allowable. Again, kapag 2001, allowable lang yun, ano? Kapag 2015, pwedeng dalawa. We have the ultimate and then we have the allowable. Okay? So again, this is NSCP 2001, NSCP 2000, NSCP 2015. So again, this is NSCP 2015. Okay? So, ayun. So we have now the 2001 and then we have the 2015. So ulitin ko, flexural backlink pa lang yan, ano? Okay, baka sabihin nyo, ganyan lang kadali eh. Okay. One mode of failure pa lang tayo, ha? So, flexural backlink. Yan pa lang ang pinag-aaralan natin. O unti-untiin natin kasi marami pa kayong subjects ngayon, di ba? Doon na ilan ba subjects nyo ngayon? Wala.
5 po ata, sir.
5 lang.
Opo.
Till
Kasama. Foundation.
foundation.
Transpo. Transpo po.
Transpo.
CPM. At saka po yung thesis.
Okay. Kaunti lang pala. So, maluwag pa naman pala kayo. Tingnan mo, wala na naman si JP. Yun. Natutulog pala, natutulog. Naka-camouflage kasi eh. Wait lang ha. May tawag na naman ako. Alright, ayan. Mukhang kumakain na si Donna, oh. Ano yan, Donna? Di ka namimigay.
Almusal ko po, sir, gulay.
Okay. Ang cute ng bill ko, oh. Ay, hindi niya kita. 28 sa Meralco. 28,114. Napaka-cute.
Then sir, 10 lang.
Hindi. Nagtatlo kasi nasira yung kontador, pinalitan nila. Ngayon ang dumating lahat.
3 buwan, sir.
Masakit. Sa puto. Okay. So anyway, let's proceed. So using NSCP 2001 and 2015, determine the allowable compressive strength. Uulitin ko ha, yung mga terms natin ha. Allowable. Anong gagamitin? ASD, LRFD?
ASD po, sir.
ASD po.
Okay. Iyan ang clue natin na allowable kapag design, LRFD naman siya. Okay? So, we will be having here for the NSCP 2015 and 2001. So, nahin muna natin si, ano ba inuwan ako dito? So, we will be having here 2001 NSCP. Okay, NSCP 2001. Again, for the problem number 1, ano? So, for the properties, let's say wala pong ibinigay na properties. Pwede kayong gumamit yung table na binigay ko sa inyo, no? So, pero dito ibibigay ko na. So, area is 7,548 mm squared. And then we have the Rx, 89.73. And then for the Ry, we have 52.03. Okay? Okay, now, with this, meron na akong value of K. So again, with fixed ends, ano ang K natin? So kanina, kung nakinig kayo doon, so you have here 0.5. Okay, pag both ends is fixed, so 0.5. Okay, so we need to check for this slenderness ratio. Okay, we have here KL all over R. Okay? Since walang ibinigay na kahit anong restrictions dun sa length, so parehas yung ating LX at saka yung ating LY. So sabi natin kanina, kapag magkaparehas si LX at saka si LY, gagamitin nating R ay yung mas maliit. So we will use the R which is the smaller, and for the W section or wide flange, it is normally the Y. Okay, RY. Palagi yun, palagi. Kapag W section, mas mababa palagi si RY. Okay, so we will be having here K, 0.5. Ang L natin is 5,700 in millimeters. All over, we will be having here 52.03. So we will be having here KL, 0.5 times 5,700 over 52.03. So we will be having here 54.75. Okay? Again, ang CC natin, kahit hindi ko na-compute, this is an A36 steel. Automatic, that is 126.17. Okay? So since, okay, KL all over R is less than CC, then this is DONA. Okay? Or this is a short column. Okay? So, gagamitin natin kapag short column, we have now the FA. Okay? So, itong formula na to. Oops, ayan yung formula na yan, yung mahabang mahaba. Okay? Siyempre, para maano natin, kailangan ulit-ulitin natin, repetition. So, walang tingin doon na, sige nga, tingin ka sa kanan, tapos i-recite mo. Hindi pa kabisado, no? Okay, okay lang. So, we will be having here as 1 minus 1 half KL all over R over CC squared multiplied it by FY all over factor of safety 5 all over 3 plus 3 all over 8 KL all over R over CC plus 1 all over 8 KL all over R all over CC, and then that is in cube. Okay? So, delete muna ako. Okay. Next. To solve for the FA, ang ginagawa natin is ini-store muna natin yung values ng KL all over R over CC. So, KL all over R over CC. So, that is equal to 54.75 all over 126.17. Ano? So, that's 54.75 all over 126.17. Okay, so that's around 0.434. Okay, store. Okay, store. Okay, so we will now have the value of our FA. Okay, calculate natin ano. So 1 minus, hindi ko na susulat, 1 minus 1 half KL over R over CC squared multiplied it by FY of 248 all over 5 over 3 plus 3 all over 8 KL over R over CC plus 1 over 8 KL over R over CC cube. Okay, so you will be having here 122.12 megapascal. Okay, and then to solve for the PA using the NSCP, so you will be having here FA multiplied by the area gross, or that's around 122.12 megapascal multiplied by 7,548 mm squared. I-divide ko na by 1,000 para maging kilo Newton. So you will be having here times 7,548 divided by 1,000. That's around 921.75 kilo Newton. Okay, so that's it. Yan yung kaya niya. Okay, that's for the NSCP 2001. How about for the NSCP 2015? Okay, so unahin natin yung ating CC. For the CC, ito constant din for NSCP 2015, kaya lang that is 4.71 square root of E all over FY. Okay, or that's 4.71 square root of 200,000 all over 248. Okay, so ang CC natin all over 248. So that's around 133 naman sa kanya, no? 133.76. Ayan, pwedeng kabisaduhin nyo na rin yan. 123.76. Again, that is for NSCP 2010. Okay, again, since KL all over R is less than CC, therefore this is DONA ulit. Okay, or short column. Okay? Ngayon, ang kukunin natin dito is kapag short column, we will be having here as our FCR. Okay? Ano yung FCR natin? So that's around 0.658 FY all over FE. Multiply it by our FY. Okay? So unahin muna natin ano yung value ng ating FE. So again, that is pi squared E all over KL all over R squared. So that is pi squared multiplied by 200,000 all over KL over R natin is 954.75 squared. So you will be having here this one all over 54.75 squared. Or that's around 658.51. Okay, again, that is in megapascal. MPa. Okay, so pwede ko nang kunin ngayon yung aking FCR. So that's around 0.658. Ang FY natin is 248 divided by 658.51. Multiplied it by 248. Okay, so I will now have the FCR. 0.658 raised to 248 all over 658.51 multiplied by 248. Okay, so you will be having here 211.83 megapascal. Okay, so we will now have the value of P sub n. So that is equals to FCR multiplied by the area gross. So that's 211.83 multiplied by 7,548. I-divide ko na by 1,000 para maging kilonewton. So you will be having here the PN. 211.83 times 7,548 divided by 1,000. So that is equal to 1,598.89 kilonewton. However, ang kailangan kasi natin is allowable. So we need to multiply it by 0. We need to divide it. Allowable tayo. So we have the PA equals to PN divided by the omega, wherein the omega is equals to 1.67. So you will be having PA equals to 1,598.89. Okay, divide by 1.67. So 1.67. So you will be having here as 957.42 kilo. Okay. So, ayan. You try to compare yung PA na NSCP 2001 and then you have here the NSCP 2015. Okay, as you can see, the NSCP 2015 gives mas maraming capacity kumpara doon sa NSCP 2001. So, yung 2001, mas conservative siya. Okay. So, in short, if you are going to design sometimes using the NSCP 2015, mas maliliit yung section ng NSCP 2015 kumpara kay NSCP 2001. Okay? Sige po, copy for a while. Okay, so let's have the next problem. Okay, so let's have the solution. Okay, NSCP 2001. Okay, so again, we need to check for the slenderness ratio. So slenderness ratio. Okay, so KL all over R. Okay, so since ang given is we have a pinned pin ends, so ang K natin is 1.0. Ang L na daw natin is around 6 meters, so 6,000 all over. Again, ang gagamitin ko, since parehas si LX at saka si LY, kukunin ko na lang yung mas mababa. So that's around 78.89. So you have slenderness ratio equal to, so 6,000 divided by 78.89. So around 76.06. Okay, so for NSCP 2001, so this is less than 126. Okay, 0.17. So this is a short column. Okay. Okay, so we will be having here our FA. So ang FA na ilagay muna natin si KL over R over CC, no? So KL over R and then divide by CC. So that's around 76.06 divided by 126.17. So 76.06 divided by 126.17. So that's around 0.603. Okay, and then store. Okay, para maano yung value. So we will be having here our FA. So again, 1 minus 0.5 or 1/2 KL over R over CC. So that's 0.603 squared. Okay, multiplied by 248. Okay, all over 5 over 3 plus 3 all over 8. KL over R over CC plus 1 all over 8. KL over R over CC. And then you have the cube. Okay, so we will be having here 1 minus 1/2 248 all over 5 over 3 plus 3 all over 8 KL over R over CC plus ay nagpa-plus ba tayo kanina? Oh, I'm sorry. Pakibago yun nyo lahat ha. It should be minus. Ngayon ko lang na ano. Bakit? Minus yun ha. So, iyan na natin. Pakita ko sa inyo. Ay. Okay. So, pakicheck nyo lahat ng sinolve natin kanina ha. Baguhin nyo yun. Dapat yun minus. So, you will be having here books. Wait, hanapin ko yung 2001 NSCP ko. Ay. Mali yun, mali. Still. Pakita ko sa inyo, ha? Hindi pwedeng, ano, mali yun. Ayun. Eto, ano? Baka meron. Effective net area, serviceability. So, you have it, this one. Okay. Ito. Huwag niyo muna intindihin yung Q. Sa ako na yan i-discuss. So, ito yung formula nun, ha? 1 minus 1 half KL over R over CC squared times FY. Ito yung factor of safety. 5 over 3 plus 3 all over 8 KL over R over CC minus, okay, pakibago lahat, minus KL over R over CC cube 1 over 8. Ano? Tapos ito yung CC natin, 2 pi squared E all over FY. Huwag niyo man naintindihin yung cube, ma'am. Saka ako ipapaliwanag yan. Alright. So, ngayon ko lang napansin. Minus 1 all over 8 cube. Okay? So, you now have the FA equals to 108.79. Okay, so change siya. Alright. So, after makuha natin si FA, okay. After natin makuha si FA, we need to solve now for the PA. So that is FA multiplied it by the AG. So we will have 108.79 multiplied it by the AG, 20,129. Okay, divide natin by 1,000 para maging kilonewton. So you will be having here this one times 20,129 divided by 1,000. So that's around 2,189.90 kilonewton. So this is now the answer for the NSCP 2001. Reiterated, minus yun. Okay. 1 minus 1 half KL over R over CC squared times FI over 5 over 3 minus 1 all over 8. Okay? Now we'll proceed. We'll have it on the NSCP 2015. Sige. I will leave the 2015 on your hands. Okay? So, ano yan? Personal consumption. Okay? I will leave that to you. So, we will now proceed with the number 3. Okay? And then sa number 3 naman, NSCP 2015 naman yung gagamitin ko. Tapos kayo naman ang bahala sa NSCP 2001, ha? Okay. Pero kapag nag-long column, parehas natin para magamit natin parehas. So, we'll try to solve both. Let us check first. So, for number 3, given properties, so area gross equals to 12,903. Okay, mm squared. And then you have here the RY equals to 65.75 mm. Okay? So, dito, ang mahalaga, sabi niya kasi, one end pinned and the other is fixed. So, kapag isa is pinned, isa is fixed, yung ang K natin is equals to 0.7. Okay? So, check natin for slenderness. So, slenderness. Okay, so you have here KL all over R. So 0.7. Ang L na gagamitin natin is 7,500 all over. R is 65.75. Okay, so 0.7 times 7,500 all over 65.75. So you will be having here 79.85. Okay. So again, if we are going to use NSCP, okay, NSCP 2015 naman ano, tapos kayo na bahala sa NSCP 2001. So we need to check it for the CC. Ang CC natin dito is around 4.71. Okay, 4.71 square root of E, 200,000 all over Fy. So you will be having 4.71 square root of E all over Fy. So that's around 133.76. Since slenderness ratio is less than CC, therefore this is a short column. Okay, so we will now have the value of FCR. That is 0.658 raised to Fy all over Fe. Multiply it by Fy. Okay, so we will be having Fe equals to, ano yung Fe natin? That's equal to our pi squared E all over KL over R. All over KL all over R squared. Okay, so we will be having here pi squared 200,000 all over slenderness 79.85 squared. So you will be having this one, pi squared E all over 79.85 squared, or that's around 309.58. Okay, so we will now have the value of FCR equals to 0.658 raised to 248 divided by 309.58 multiplied by 248. So FCR natin 0.658 raised to 248 all over 309.58. That's around 177.35 megapascal. Okay? And then solving for the value of En, so we will be having here the Pn equals to FCR multiplied by Ag. So 177.35 multiplied by the gross area, 7548. Okay? Divide natin by 1,000. So we have now the nominal. 177.35 times 7548 divided by 1,000. So you will be having 1,338.64 kilonewton. Since allowable ang hinahanap natin, so we will be having here as Pn all over omega, or that is Pn all over 1.67. So 1,338.64 divided by 1.67. So that would be your allowable, and 801.58 kilonewton. All right. So this is now the answer for 3. And for the NSCP 2001, personal consumption. Okay, copy muna ulit, and then we'll go with the last problem.
Sir? Sir?
Po, yes. May ano ba? Concern?
So, hindi ka po yung AG na gagamitin ay
Ay,
12,903?
yes! Ayun. Ay, ito pala yung nakita ko.
Ayun
Ito
po,
pala yung
sir.
nakita ko. Okay. Thank you. Thank you, Donna.
Sige po.
Okay, kayo na magbago, no? Tinatamad ako eh.
Sir, at saka po dun sa ano, sir? Sa
Saan?
FY po, sir.
Sa FY. Ay!
Opo, sir.
Oo. Ayan, at
Pero
least,
tama naman po.
nakakorek nga ako, ano? So, tama yan, ha?
Sige.
Hindi ko napansin eh, sorry. Kala ko 836 pa rin ako. Mahilig sa 836. Okay, anyway, sige. I'll try to change. So, 79, ito, tama ito. So, ito, babaguhin natin. Gagawin natin yung 345. So, that's 4.71 square root of E, 200,000 all over Fy. So, that's 345. So, this one would become equal to 113.40. Okay? So, again, still, i-check natin yung CC. No? So, meron tayong value ng CC. So, that is equal to... ito na pala yung CC natin. Tama ba? Okay, tama. So, since short pa rin siya, so 0.658 raised to 300. Okay, ito baguhin natin. Okay, so 345 all AE muna. Ito tama. Okay, so mababaga. Okay, ito that is 345. So 0.658 raised to 345 all over 309.58. Okay, multiplied it by 345. So that's 345. So you will be having here 216.40 megapascal. Paki-check na lang ha. So ito totally mababago. So that's 216.40 multiplied it by 12,903. Okay, and then divide by 1,000. So 216.40 times 12903 divided by 1,000. So this PN is now 2792.15 kilonewton. So bago, 2792.15. Okay, divide by 1.67. So you will be having here PA equals to 1671.94. Okay. Yan, hindi ko napansin. Nawili sa 836. Okay, so let's have the problem number 4. So ito, built-up section na to, no? Okay, although sabi sa NSCP 2015, kapag built-up section, we need to check for the flexural torsional or torsional buckling. Pero nandun pa lang tayo sa first mode of failure natin, which is the flexural buckling, ano? So yun lang yung isa-solve natin as of now. Okay? So kapag built-up section, we need to check first the total area. Okay? So let's have the total area. So yung isang area, times 2 ko na lang. So hatiin ko sa dalawa. Ito naman daw ay 200 by 200 by 22. Ibig sabihin ng 200, yun yung length ng isang leg. Tapos yung 22 na number, iyon yung inyong thickness, no? Yung 2L, ibig sabihin, 2 angles. Okay? 2 Ls. Ayan, dalawa. 1, and then you have the 2. Okay? So, unahin ko muna to. This is around 200 multiplied it by 22. Okay? Tapos, isusunod ko to. Kaya lang ito, bawas na ng 22. Ano? So, that's 200. Okay? So, 200 minus 22. Ito yon yung width na yon. And then, multiply it by thickness na 22. Okay? I-multiply ko na lang times 2 kasi dalawa yung angle mo. So, you have here the total. Okay? So, we have here 200 times 22 plus 200 minus 22 times 22. Okay? And then times 2. So, you will be having here 16,632 mm squared. Okay? So, you will be having here the total area of that one. Okay? 16. 632.32. Next, we need to find the location of our bar Y. Okay. Okay, we need to find the location. Kasi yung bar, ito, alam na natin to kung saan gitnang-gitna yan because of the symmetry. Ano? Sabi natin, sa statics, kapag symmetrical, automatic, nasa gitna. Kaya lang ito, hindi natin alam. Okay, so we need to find for that bar Y. Okay? So, sa bar Y mo, okay, dapat alam muna natin yung bar Y ng isa. Kasi kung nasaan yung bar Y ng isa, based on this one, okay, parehas lang sila na. Okay, bar Y. Okay. So, kumbaga, ang gagawin natin, we need to cut it one element. Okay. Okay. Tapos, ay, dalawa to, no? So, isa to. Ito isang area. And then this is the second area. Okay. We need to locate kung nasan yung ating bar Y. Okay. So, itong area na yon, meron yung layo mula doon hanggang dito. So, that is Y1. Tapos, ito yung pinaka gitna nito. So, you will be having here our Y2, no? And then, nahanap natin kung nasan yung ating bar Y. Okay. Sabi natin sa Barignon's theorem, yung area niya ng buo, yung buo ano. And then bar Y is equals to, we'll call it as area 1 and we'll call it as our area 2. So area 1, ito pala area 1, ito area 2 no kasi para 1. So we have Y1, A1, Y1 plus A2, Y2. So parang ganyan. The sum of all the moments of the areas is equals to the sum of the moments of the whole area. So ito, kasi ito dalawa to eh. So i-divide ko na lang by 2. So 16,632 all over 2 no. Okay? And then bar Y kasi isa lang naman hinahanap ko, isang area lang. So you will be having here yung area 1, ito daw yung area 1 ko, yun yung 200. Okay, minus 22 multiplied by 22. Okay, itong area na yon. And then mula sa pinakababa, yung gitnang-gitna niya, it is height all over 2. So, that is 22 all over 2. Okay. Yung area 2 ko, yun yung aking 200 by 22. Okay? Ito yun, ano? Ito yun, yung area na yun. So, that's 200 by 22. And then, its moment arm, mula sa baba, kalahati ng 200. So, you will be having here 200 all over 2. So, with this, the only unknown is you have here now the bar Y. Okay, so 200 minus 22 multiplied by 22 multiplied by 11 plus 200 times 22 multiplied it by 200 all over 2. Okay, divide natin by kalahati ng 16,632. Okay? So you will be having here as there's something wrong. 200 times 22, 200 minus 22 times 11 plus 200 times 22. Ayun. Times 100. Okay? So that's around 58.09 mm. Okay? So para sa isa, ganun ano? Dalawa naman sila for this one. Ang centroid niya ngayon is located at 58.09. Okay? So, sir, bakit ba kailangan yan? Okay. Again, if that is the case, and then this one, okay, delete ko muna. Kailangan kasi natin makuha yung Rx at saka yung Ry niya, di ba? So, para na makuha natin si Rx and then si Ry, so pupunta tayo sa square root of I all over the area. So, yung area, meron na tayo, no? So, we will now have the area. So, ang wala na lang tayo is the value of I. Unahin natin si Ix. Okay? So, originally, nandito yung I niya. Okay? So, this is now your Ix. Okay? Diyan din napunta. So, yung single I. Okay? Yung single I nito. So, yung area 1 is, again, BH cubed. Diba? May BH cubed all over 12 plus area. So, BH multiplied it by Y bar minus Y1 squared. Okay, iyan yung I plus AD squared. Okay? So, if you still remember that. Yung I ng maliit, we have here, ito. Okay, dalawang area pala yan. Sige, iyan ako na to. So, this is 200 minus 22, no? Ito is 22. Tapos, yung isa is ito. Ito yung 22, ito yung 200. Okay? Tapos, originally, ito yung kanyang X. Tapos, ito, nandito yung kanyang X. Ito yung X sub 1, ito yung X sub 2, no? Okay? And then, nung pinagdikit ko sila, okay, nung pinagdikit natin silang dalawa, parang ganyan. Okay. Napunta dito yung pinaka X natin. Okay? So, that is now your X. Okay? Ngayon, yung distance ng X sub 1, ng X sub 2, dun sa X sub 2, dun sa X sub 1, bakit ayaw? Wait. Yan. Okay. Ito yung aking D2. Okay. Distance from the bar X doon sa aking X sub 2. So, ito, mula dito hanggang doon, ito naman yung aking D1. Okay? So, kung kukunin ko yung single I ng angle, okay? So, we will be having here the Ix is equals to I of X sub 1 plus area 1 D1 squared plus Ix of 2 plus area 2 D2 squared. Okay? So, saan yan nanggaling? So, review lang tayo na iyan yung summation ng I plus AD squared. Transfer formula. If you still remember the transfer formula, balik kayo ng statics. Okay? So, unahin natin to. I ng X sub 1. So, yung 200 minus 22, so that's around 178, ano? So, that's 1. So, BH cube all over 12 plus the area, 178 multiplied it by 22. And then yung distance D1, this is actually the bar X. Yun yung bar X mo. Ayan, malilito na kayo dito, no? Pero yung distance na yon, okay, remember, this is wait, equal to bar y minus y sub 1. Meron na tayong y sub 1 kanina, di ba? Ito yon, tsaka yung bar y. Iyon yung distance nilang dalawa eh. Okay, so ito yung ating D1. Tapos, yung distance nitong dalawa, ayun, iyan naman yung inyong D2, no? So, parang ganun. So, with this, yung bar y ko na nakuha, which is 58.09, ima-minus ko yung bar y ng isa, which is 22 all over 2, or that is 11. Okay, squared. Okay? So, ito is para sa area 1. So, para sa area 2, 22 multiplied it by 200 cube all over 12. Plus the area, 22 times 200. Okay, nasa naman yung distance na yon? So that is actually, distance 2 is bar y minus y sub 2. Okay? So ang bar y natin is 58.09 minus ating y sub 2 is actually 200 all over 2. So we have here 100 squared. Magne-negative yan, okay lang kasi naka-squared naman siya. So no problem with that. So I will now have the Ix for a single angle. So we will be having here 178 multiplied by 22 cube all over 12 plus 178 times 22 times 58.09 minus 11 squared. Okay. And then you will be having here 22 times 200 cube all over 12 plus 22 times 200. The 58.09 minus 100 squared. Okay. Pagsasamahin yon. So you will be having here 31 times 10 to the 6 ko na. So 31.24 times 10 to the 6 mm to the 4th. Okay. Meron ka ng Ix for the single, no? Now, ibig sabihin, dito sa line na to ng single, iyan yung inyong Ix. Okay? So, meron ka ng Ix. Now, for the single, since pareha sila, no? Pareha sila ng legs, meron din yung Iy. Kasi nandito yung centroid ng isang angle eh. Tama ba ako? Nandyan yung centroid ng isang angle eh. Okay? But since same sila ng legs, I can conclude that Ix is also equal to my Iy. Pareha sila, no? For the single angle. So, para dito sa buo, kumbaga, nandito yon. Ito yung dati mong centroid. Ayan. Dati mong centroid, no? Kaya lang, nung pinagsama ko na silang dalawa, nabago na yung centroid. Ito na yung centroid natin. Okay? Tingnan natin yung X. Yung dating Ix, napunta dito. So, this is now your Ixx, no? Ibig sabihin, pag Ixx, ano siya, built up section, ano? Nabago ba yung location ng X centroid? Hindi. So, kung hindi siya nabago, itong term na to na AD squared, mawawala. So, in short, yung Ixx ko, it is just equal to summation of Ix. Parehas lang silang dalawa. So, ito times 2 ko na lang. So, 31.24 times 10 to the 6. So, you will be having here times 2. So, you will be having here 62.47 times 10 to the 6 mm to the 4th. Okay? Ngayon, tingnan natin sa y. Meron ka dito, nandito yung original Iy mo, no? Okay, nandyan yung original location. Kaya lang this time na bago. Ita-transfer natin doon yung bagong centroid. So, gagamitan natin ito. Okay, so for the Iyy, since dalawa sila, i-times 2 ko na lang. Yung single Iy, ito yon. So, that is 31.24 times 10 to the 6. Plus, magta-transfer ako. Yung single angle, again, naka-single angle to, no? So, dapat ito, single angle din. So, area ng single, divide ko lang by 2, 16,032. 8316, no? Okay, single angle. So, yun yung gagamitin kong area. So, 8316. Sir, ano yung magiging distance? Distance nito hanggang doon. Kaya kailangan ko yung separation kasi kalahati nun. So, ang kalahati nun is 5 mm. And then mula dito hanggang doon, iyon yung kinuha nating bar Y na 58.09. So, since sabi ko nga pareha sila ng legs, yung bar X ko at saka yung bar Y ko is also the same. Okay? So, in short, this one would become 58.09. Mula dito hanggang dun sa pinaka-edge, iyon yung 58.09. Tapos magdadagdag ako ng kalahati ng 10. Okay? So, this is now your IYY. Okay? So, 2 times 31.24 times 10 to the 6 plus 8316 multiplied it by 58.09 plus 5 squared. Okay? Or that's equal to 130.68 times 10 to the 6 mm to the 4th. Okay? Between the two, the governing, sabi ko nga kanina, we need to check for the R. Hindi pa tayo tapos kasi I pa lang yung nakuha natin. Okay. Since I pa lang nakuha natin, we need to check for the Rx. Pili na tayo ng mas maliit kasi parehas naman yung L niya eh. So wala namang binigay na restriction. So pili tayo ng ano mas malaking, mas maliit na X. RXX tayo. Okay, so that would become equal to the square root of IXX all over total area. Okay, so we will be having here IXX natin is 62.47 times 10 to the 6 divided by the total area 16,632. Take note ha, yung IXX ko dalawang angle na yon. So ang gagamitin kong area dalawang angle din. So you have your square root of 62.47 times 10 to the 6 over 16,632. So you will be having 61.29 mm. Okay? Pag meron ka na yan, pwede na tayong kumuha ng slenderness ratio. So that is KL all over RXX. So ang K natin, sabi niya, gusset plate pin ends 1.0, ang length is 7,400. All over, the RXX is 61.29. So we will be having here 7,400 divided by 61.29. And then you have here 118.99. Okay? So 836 ang gamit. Okay, ang iso-solve natin, sige, I will solve for the NSCP 2001. Okay, so check natin yung CC natin, that's 126.71. So since slenderness ratio is less than CC, therefore this is a short column. Okay? And then, computin natin yung KL all over R over CC. So, that's around 126.71. So, 0.939. Okay, store natin. Okay. And then, with this formula, okay, kukunin natin yung ating FA. Okay, hindi ko na isusulat. So, we will be having here as 1 minus 0.5 of KL over R over CC squared times 248. 5 over 3 plus 3 over 8 over CC minus 1 all over 8. Yun. KL over R over CC cube. Okay. So, you will be having here 72.39 megapascal. Okay. So with this, pwede na natin kunin now si PA. So PA is just equal to FA multiplied by the gross area. So ito yung gagamitin kong gross area, no? So times 16,632. And then divide by 1,000. So you will be having here 1,203.99 kilonewton. Okay? So this is now the answer for this one. For 2015, ulitin ko, personal consumption. Okay. Ano ang key sa steel design? Ang key sa steel design, pagkuha ng moment of inertia. So you should master how to compute for the centroid and how to compute for the moment of inertia. Okay? Kasi kapag hindi nyo natutunan yung moment of inertia at centroid at radius of gyration, hindi kayo papasa sa akin. Okay? So that's the time na ibabagsak ko kayo, ibabalik ko kayo sa statics. Okay, kopya muna. Sige. So, yun yung nakikita nyo sa bubong na madalas, di ba? Magkapatong na ganun yung dalawang angle bar. Okay, mukha lang siyang madali gawin, pero sa computation, mas mahirap siyang gawin. Question po? Yes, Donna, meron? Hindi kita marinig.
Sir, wala po.
Ha?
Wala po. Wala pa naman po, sir.
Si M.
Sa ngayon po.
Ha?
Wala pa naman po, sir.
Well.
Wala pa rin, sir.
Okay. Si Juris. Wala si Juris dito.
Sir, hindi ko pa naabutan ang 4.
Ah, ganun ba?
Nag-busy po ako.
Okay lang. Si Manilyn. Wala. Si Dan.
Nalilito pa, sir, pero pag-aaralan ba?
Sige. Nakakalito yung ano lang, pagka moment of inertia. Pero I guess the process na sundan yun. Naitama nyo nga ako kanina eh. So, tama yun ha. So, yun lang yung process. So, kumbaga ngayon, pag pinagsasama-sama lang natin. O, yung natutulog, Marquez.
Hindi po.
Hindi ka natutulog. Okay, so ganun na. Yun ang mahalaga. Ang lagi lang natin sa ngayon ha, we need to check first the slenderness ratio. Determine if it is a long column or a short column. Tapos, apply the formula. So, dalawa lang naman yung formula niyan. It's either long column or short column, no? And the next week pala inyong prelim. So, on the next meeting, i-consider na natin yung local instability. So, yung local instability, magkakaroon tayo ng, di ba, meron tayong dalawang buckling. We have the general buckling. Iyan yon, yung flexural buckling natin. And then, consider natin yung local buckling. So, kung masisira ba siya within dun sa locality niya, no? So, same pa rin yung formula, may idadagdag lang tayo, yung kaninang Q. Okay, so, but that's on the next meeting na, no? So, for now, you study on the tension member. Iyon lang yung inyong magiging exam. Okay? On tension member, where it is on the yielding, on the rupture, and on the block shear. Especially on the design, baka pag-designin ko kayo, no? So, you try to study on the design parts. As well as, of course, the threaded rod. Okay, so meron din tayong threaded rod. Okay, so kung wala nang question, so let's call it a day. It's 10:42. So, yung time nyo, gamitin nyo again for the review. Okay? So, kawawa naman yung mga nagpipiso net lang. Napakamahal na ng bill nila. Okay? So, sige po. So, if you have question, may group naman. So, you may ask there or doon sa ating Google Classroom, no? I guess, minomonitor din tayo yung activity natin ng WIS. So, kasama natin sa group yung HR doon, yung WIS HR. So, if you no more question, again, see you next meeting and thank you very much.
Thank you po, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, bye-bye.
Sir.